Good day everyone, this is the group 4 and for this video we will be talking about the broken line graph. So without further ado, let us get started.
What is a broken line graph? So a broken line graph connects data points with line segments with different slopes. The line in this type of graph is more disjointed or broken compared with another type of line graph called a linear line graph. A linear line graph has data points that are connected by lines with a specific and steady slope. And what does a broken line graph looks like? A broken line graph is a type of line graph that connects with the data points with line segments. The lines do not have consistent slopes and can have positive and negative slopes. And now let's proceed to the history of the broken line graph.
The history of the broken line graph, also known as the line graph or polyline graph. It was actually not invented by an individual. Still, it evolved through contributions from various scholars and practitioners in statistics, mathematics, and data visualization. The concept of representing data using a series of connected line segments, which is the essence of the broken line graph, can be traced back to earlier times, particularly in the field of cartography and navigation. One of the earliest examples of graphical representation of data resembling a broken line graph is found in ancient maps and navigational charts. Mariners and cartographers used lines or tracks to depict routes taken during voyages, with segments indicating different lengths of the journey or points of interest along the way. However, the systematic use of line graphs for statistical data visualization emerged later, particularly in the late 17th and early 18th centuries, with the work of scholars such as René Descartes and Johann Heinrich Lambert. Descartes introduced the Cartesian coordinate system, which laid the groundwork for plotting mathematical functions as continuous curves. Lambert, building upon Descartes' work, developed methods for representing mathematical functions graphically, including the use of line segments to connect discrete data points. So basically, these two mathematicians their works serve as a path for graphs. The concept of representing data points on a graph dates back to the 18th century with the work of William Playfair. Playfair's invention of line charts in the late 18th century laid the groundwork for the broken line graph. On the picture on the left is a line graph showing England and Scandinavia's import-export balance for the 18th century from Playfair's 1786 Political and Commercial Atlas. The second pic on the right, is actually the world's first bar chart from the Commercial and Political Atlas, shows the relative importance of Scotland's trading partners. So it was actually William Playfair that really expanded and contributed with the discovery of line graphs. But sadly, William Playfair died poor and was actually shunned from society. It took 100 years later, a century, for the people to appreciate his work, for graphs to be relevant again. Statisticians and researchers use broken line graphs to visualize experimental data, trends, and correlations. With the advent of digital technology and computer graphics, the broken line graph went under a transformation. Today, broken line graphs continue to be extensively used across various disciplines, including finance, healthcare, engineering, and environmental science.
So now let us move on to the description of a broken line graph. A broken line graph, also known as a line graph with gaps, visually represents data points connected by line segments. It is used to illustrate trends or changes over time. but with interruptions in the line to signify missing or unknown data points. This type of graph emphasizes the available information while highlighting gaps in the dataset, providing a clear visual cue for areas where data is not present. Unlike a standard line graph where a continuous line connects all data points in the sequence, a broken line graph introduces breaks or gaps in the line to indicate the absence of data for certain periods or categories. This method allows the graph to accurately reflect discontinuities in the dataset, providing a visual representation that is both honest and informative. The broken line graph also has its key features. First are the data points, which are represented by markers or dots at each available data measurement, the connecting lines, which are lines that connect consecutive data points to depict trends or changes over time, and lastly, the gaps, which are explicit interruptions or breaks in the connecting lines, highlight the lack of data for specific intervals. The broken line graph also has its purpose and benefits. First is its transparency, where it clearly indicates where data is missing, promoting an accurate interpretation of the available information. Next is the trend analysis, where it allows for the visualization of trends while acknowledging data limitations. And lastly, the data integrity, where it maintains the integrity of the dataset by not interpolating or guessing missing values, making it ideal for datasets where missing data is a significant factor. In summary, a broken line graph is a nuanced tool for data visualization, adept at balancing the depiction of trends with the candid acknowledgement of data imperfections.
And now let's move on to the definition of terms. First we have histograph. It's a diagram that illustrates the relationship between two variables usually measured at the right angles along one of the pairs of axes. Second is the time points, are plotted on the y-axis to illustrate how the data changes over time, and the related data values are depicted along the x-axis. Third is the data. Show various quantities, observations, or measurements pertaining to a particular variable, such as the time, temperature, sales, or any other measurable element. Fourth is the y-axis. Represents the graph's vertical axis. It is the plotting location for the data values corresponding to each time point. Fifth refers to the disconnected or non-continuous line graph segment. It indicates that the line's various sections are separated by gaps or breaks. Lastly is the x-axis. This represents the horizontal axis of the graph. It is where the time points or other independent variables are plotted.
How to make a broken line graph? Step 1. Identify the variables. 2. Determine the variable range. 3. Determine the scale of the graph. 4. Number and label each axis and title the graph. 5. Determine the data points and plot on the graph. 6. Draw the graph or draw a curve or a line that fits the data point. Now, let's use the steps or procedure in making the graph. Here is a sample data to make it into a line graph. Step 1. Identify the variable and the independent variable previously changed with experiment 2. Number of glues, dependent variable, changes with the independent variable and is measured number of crayons. Step 2. Determine the variable range. Subtract the lowest data value from highest data value for each variable. Range of crayons 14 minus 4 equals 10. Range of glues 20 minus 5 equals 15. Step 3. Determine the scale of the graph. Determine the numerical value for each grid unit that best fits the range of each variable. Number of lines in graph is 36, y-axis. Range of 10 crayons and number of lines is 36 lines. Number of lines on graph is 25 in x-axis. Range of 15 glues and number of lines is 25 lines. Step 4. Number and label each axis and title the graph, average number of crayons versus number of glues. Step 5. Determine the data points and plot on the graph. 5 to 4, 10 to 7, 15 to 11, 20 to 14. Step 6. Draw the graph, draw a curve or a line that best fits the graph data points. Do not connect the dots as the number of glues increases. More crayons are picked up with the electromagnet.
Sample problem number 1. The temperature in a city was recorded every hour for a day and plotted on a broken line graph. The graph shows the temperature at 12 p.m. as 25 degrees Celsius, at 3 p.m. as 28 degrees Celsius, at 6 p.m. as 30 degrees Celsius, and at 9 p.m. as 26 degrees Celsius. What was the temperature at 2 p.m.?
To find the temperature at 2 p.m. using the given information, we can assume the linear increase in temperature between the recorded values. So from 12 p.m. to 3 p.m., the temperature increased by 3 over a span of 3 hours. This means the temperature increased by 1 Celsius per hour. To estimate the temperature at 2 p.m., we can calculate the difference in time between 12 p.m. and 2 p.m., which is 2 hours. Since the temperature increased by 1 Celsius per hour, we can add 1 Celsius for each hour to the temperature at 12 p.m. Starting at 25 Celsius and adding 1 Celsius for each hour, we can estimate the temperature at 2 p.m. as follows: 25 Celsius plus 1 Celsius and add another 1 Celsius equals 27 Celsius. Therefore, the estimated temperature at 2 p.m. is 27 Celsius.
Sample number 2. The number of visitors to a museum was recorded every 2 hours for a day and plotted on a broken line graph. The graph showed the number of visitors at 10 a.m. as 50, at 2 p.m. as 120, at 6 p.m. as 180, and at 8 p.m. as 200. What was the number of visitors at 4 p.m.?
So, to find the number of visitors at 4 p.m. using the given information, we can assume a linear increase in the number of visitors between the recorded values. From 10 a.m. to 2 p.m., the number of visitors increased by 70 over a span of 4 hours. This means the number of visitors increased by 70 over 4 equals 17.5 visitors per hour. So, to estimate the number of visitors at 4 p.m., we can calculate the difference time between 2 p.m. and 4 p.m., which is 2 hours. Since the number of visitors increased by 17.5 visitors per hour, we can add 17.5 visitors each hour to the number of visitors at 2 p.m. So, starting at 120 visitors and adding 17.5 visitors each hour, we can estimate the number of visitors at 4 p.m. as follows. So, 120 visitors plus 17.5 and add another 17.5 equals 155 visitors. Therefore, the estimated number of visitors at 4 p.m. is 155 visitors.
Sample number 3. The table shows that number of books read by a student over a period of 5 months. This line graph shows that 10 books were read in January, 15 books in February, 12 books in March, 18 books in April, and 20 books in May. Questions. Question number 1. How many books did the student read in February? Number 2. In which month did the student read the fewest books? Number 3. What was the average number of books read per month over the given period?
To represent the data on the broken line graph, imagine a graph where the x-axis represents the months from January to May and y-axis represents the number of books read. You start at January with a point at 10 on the y-axis, then draw a line to February at 15, continue the line to March at 12, then to April at 18, and finally to May at 20. This visual representation shows changes in the number of books read over a specified months. Now, to answer your question, the answer of question number 1 is in February, the student read 15 books. The answer of question number 2 is the student read the fewest books in January with a total of 10 books. So, to answer the question number 3, you must find the total number of books read from January to May and add it all. So 10 plus 15 plus 12 plus 18 plus 20 equals 75 books. There are 5 months in total, so the average number of books read per month is 75 divided by 5 equals 15. So therefore, the average number of books read per month over the given period is 15 books in total.
For us to interpret a broken line graph, we must follow these steps. First, look at the lines. Follow the lines and notice if they go up, down, or stay the same. Second, see where they connect. Pay attention to where the lines meet or have breaks. This tells you when there's a change in the story. Third, think about what it means. Just like in a story, try to understand what those changes could mean. Are things getting better, worse, or staying steady? Fourth, remember what it's about. Keep in mind what the graph is talking about. Is it about grades, temperatures, or something else? Then fifth, tell the story. Put it all together and explain what's happening in the graph. Describe the changes you see and what they might mean in real life. Interpreting a broken line graph is like reading a simple story about how things change over time. Problem number 1. The answer for problem number 1 indicates that the temperature at 2 p.m. is slightly higher than the temperature at 12 p.m. but lower than the temperature at 3 p.m. Therefore, the temperature is rising during this period. Problem number 2. The answer for problem number 2 suggests that there is an increasing number of visitors to the museum from 10 a.m. to 4 p.m. This indicates that the museum experienced a growing level of attendance during this time period. The answer from problem 3 reveals several trends in the students' reading habits over the 5-month period. In February, students read 15 books, marking an increase from previous month where they read only 10 books. This suggests that the students' reading activity increased in February. January had the lowest number of books read, with the student reading 10 books only. The average number of books read per month over the given period was calculated to be 15 books. This indicates a relatively consistent level of reading activity throughout the 5 months. Overall, the data indicates a generally rising trend in number of books read by the students, with fluctuations in specific months. Despite the temporary decrease in March, the students' reading habits appear to be trending upwards over the observed period.
So to wrap it up, a broken line graphs are more than just a line on a chart. They are powerful tools for understanding data. Understanding and interpreting broken line graphs is essential for unlocking valuable insight hidden within complex data sets. By studying the trends and patterns they reveal, we can gain valuable insight into various phenomena, whether it's tracking temperature changes through the day or monitoring visitor numbers at a museum. Broken line graphs helps us see the bigger picture. Embracing the nuances of broken line graphs empowers researchers to navigate data uncertainty, like uncover underlying phenomena and derive impactful outcomes in the various fields of studies. Interpreting broken lines isn't always straightforward though. We need to consider factors like missing data points and changes in measurement methods. By carefully analyzing the graphs and understanding its context, we can make more informed decisions and draw meaningful conclusions. So always remember that mastering the art of interpreting broken line graphs is the key to unlocking the full potential of your data analysis endeavor.
So that ends our report about broken line graphs. I hope you enjoyed this video and I hope you learned something. Thank you so much for watching!